Welcome back. In this video, we are going to learn about the Internet Protocol or IP. So let's look at the agenda. We start with internet networking concepts, then IPv4 followed by the next generation IPv6. Now let us look at the internet networking concept. Let us understand this internet networking with the help of this example. This example consists of 4 different LANs and a single WAN. LAN A, LAN B, LAN C and LAN D. And there is a single WAN. Now, the physical layer and the data link layer are responsible for node-to-node data delivery within a single network. And whenever data must be sent from LAN A to LAN B, suppose data goes from LAN A, from data link layer to physical layer and through this link F1, and it goes to the router R1. But there is no way that the data can be passed from a node in LAN A to a node in LAN B because it is in a different network over the WAN. So, in other words, host to host data delivery is not possible by using this connection. So, what is the solution? The solution is introduction of the network layer. So, we have used here the network layer, and network layer basically has the capability to introduce the IP address or the logical address of the receiver node, maybe in a different network. So, the network layer or the internet layer of the TCP/IP protocol suite is used for internet networking purposes. So, whenever you are giving the network layer, it enables the communication to know that it has to go over the link F1 to the router R1, and the network layer of the router R1 also has the understanding that it has to go over the link F3 to router R2 over this WAN and ultimately to a particular node in LAN B. So, there are various functionalities of the network or the internet layer as we will see right away. So, let us see what is the functionality of the network layer at the source, network layer at the destination and network layer at the router as per the previous example. You see, at the source, the data from the upper layers, in this case the transport layer, go to the network layer. Here, after the processing is done, it looks into the routing table that has all the source and the mapping of the destination IP addresses from the routing table. It forms the IP packet. So, IP packet, it gives the payload. So, the payload means the user data, and together with it, it appends the header. This header consists the IP address of the destination computer. Now, what happens at the router? At the router, again, this IP packet from the data link layer comes and it is then processed. After processing with the help of the routing table, it forms the IP packet plus the routing information, and it then passes to the data link layer to the next link. In this case, it is F3. Now, what happens at a destination computer? At the destination computer, from the data link layer, we get the packet, this IP packet. Then after processing, it understands that this is the destination and it supplies the data to the destination computer, and the data goes to the upper layer, in this case the transport layer. Now, we have earlier learned about the datagram approach. Now, this was taught in switching communication part. There are three different types of switching communication. One is called the circuit switching. The second one is called the datagram approach, and the third one is called the virtual circuit switching. Now, this virtual circuit switching and the datagram approach together, they are known as packet switching. Internet uses the datagram approach to send packets over the internet from one source to the destination. Now, in order to transfer the packets from the source to the destination, there can be two approaches. One is the connectionless network approach and the other one is the connection-oriented approach. Now, if you recall, circuit switching uses connection-oriented approach. In connection-oriented approach, a proper path must be established between the source and the destination before the packets are transferred. Then after the packets are transferred, then there will be a termination of the path. Whereas in connectionless approach, no path is established before transfer of data. Here each packet is treated as an individual message. Now, since you have the internet, let's say we have the source and the source is connected to the destination through the WAN. Now, this WAN again consists of several different routers and it can also have different protocols that are in use. So, it is very difficult for a source at one end of the internet to establish the connection to the destination computer at the other end of the internet. So, internet uses connectionless approach. Here it means that no path is established before the data is delivered. All the packets are treated as individual messages and they are then passed from the source to the destination. Let us now turn our attention to IPv4. Let us understand the concept of IPv4. In IPv4, there are 5 layers, as we have already seen in TCP/IP protocol suite. There are 5 layers: the application layer, the transport layer, the network layer, the data link layer, and the physical layer. The application layer protocols are SMTP, FTP, Telnet, DNS, SNMP, NFS, RFC, and TFTP. So these are some of the protocols of the application layer. Then the transport layer has the protocols TCP and UDP. TCP is the connection oriented protocol and UDP is the connectionless protocol. At the network layer, we have ICMP, IGMP, IP, ARP, and RARP. At the data link layer and at the physical layer, there we have the underlying LAN and WAN technologies. So we can see that IP stands at the network layer, and this is the position of IP in IPv4 TCP/IP protocol suite. Let us now look at the frame format of IPv4. IPv4 has a header part and a payload part. This payload part is called the user data, and the header part basically is contains the controlling information. So there are 20 to 60 bytes in the header, and together the header and the payload consists of 20 to 65536 number of bytes. Now the header part consists of several fields. The first field is a 4-bit field which indicates the version number. In this case, it is the version 4. followed by 4 bits of header length, then 8 bits of service type. Mostly here we have differentiated services. The next 16 bits consists of the total length of the datagram. After that, we have identification consisting of 16 bits. This is mainly used for fragmentation. Then we have the flag bits, which are the 3 bits. Then we have fragmentation offset, which consists of 13 bits. Then we have 8 bits of TTL, also called time to live. Then we have 8 bits of protocol here. This defines the type of protocol. The values and the protocol types are given here. If the value of this is 1, it means it is ICMP protocol. If the value is 2, it is IGMP. The value is 6, it is TCP. The value is 17, it is UDP. The value is 89, it is OSPF. Then we have the 16-bit header checksum, followed by 32-bit IP address, source IP address, then 32-bit destination IP address, followed by the options field. So this is the frame format of IPv4. Let's now turn our attention to IPv6. IPv6, as we have learned, has several advantages. It has a large address space as compared to IPv4 because the number of bits is 128 and so address space will be 2 to the power 128. It has a better header format. It has a new options field and it has allowance for extension. It has resource allocation support and it has more security support as well. Let us now look at the packet format. There is a 40 bytes of base header followed by the payload or the user data consisting of up to 65535 bytes. Now in the payload type again we have the extension header or which is optional followed by the data part. This is the format for the packet and we can see here it starts again with the version field of 4 bits. Then there is a priority or the traffic class field having 8 bits followed by 20 bits of flow level. Next we have the payload length of 16 bits followed by the next header of 8 bits. Now let us concentrate on next header. Now let's see if the next header code is 0, it means hop by hop option. If it is 2, it means ICMP. If it is 6, it means TCP. If it is 17, it means UDP. If it is 43, it means it is source routing. If it is 44, it is fragmentation. If it is 50, it is encrypted security payload. If it is 51, it means authentication. If it is 59, it means null or the no next header. If it is 60, it means destination offset. This is followed by the hop limit of 8 bits after the next header. Then there is a 128-bit source address followed by 128 bits destination address. Then there will be some extension headers followed by the data field. So this is the packet format of IPv6. Let us compare IPv6 with IPv4. These are some of the differences that I have jotted down of IPv4 and IPv6. Initially, the header length that we had in IPv4 is eliminated in IPv6 because we have a fixed header. Service type in IPv4 is eliminated in IPv6 and we have introduced a priority field and a flow level field. The total length in IPv4 is eliminated in IPv6 and we have given a payload length field. Identification, flag and offset are eliminated in IPv6 that we had in IPv4 and we have introduced this extension header which basically means the fragmentation in IPv4. Then time to live in IPv4 now is called the hop limit. The protocol field in IPv4 is now called next header field in IPv6. The header checksum is eliminated. We had the header checksum in IPv4. It is eliminated in IPv6 because the security is provided by the upper layers. Then options field is implemented as extension headers in IPv6. To summarize, in this video, we have learned about internetworking concepts, we have learned about IPv4, and we have touched upon IPv6. Then we have made a comparative analysis of IPv4 and IPv6 headers. Thank you.